Hey kids, Mr. Murray here on Mr. Murray's Mathland channel, and we're going to talk today about solving log equations. And these are basically going to boil down to one of two cases at this stage of the game for you guys. Case one will be if you can get it down to, by using log properties or manipulating in some way, you can get it down to the log equals a number. It could be a different base, but if you can get it down to this, log equals a number, well then your next move should be, now I don't know about obvious because logs aren't that obvious to people, but it's certainly something we've dealt with. To get rid of the log, we rewrite it in exponential form. If I can get it to here, then my next move is to switch it to, hey, base b to the c equals a, and then solve from there using whatever algebra. I don't know which part will be the variable, but the log will be gone then. And case two is actually even easier if you can get it there. Again, it might require some condensing or some power properties, manipulating, but if you can get it down to log equals another log, and of course they have to have the same base for you to do this, but if you can get it down to here, notice again there can't be any coefficients or any extra constants being added or subtracted outside. You can get it down to just log of a equals log of c. A log of something equals another log. Well, then the only way that's true, this is what they call the one-to-one property, is if the two arguments are equal. You basically just drop the logs. So if a equals c. So those are your two real moves, and everything you encounter should boil down to one of those two scenarios. Either log equals a number or log equals log. So just keep that in mind. Those are your two goals. It may look confusing depending on the initial problem, but if you whittle it down, you can get down to one of those two scenarios. So here's an example. Number one, we have ln of x minus 9 plus ln of x plus 2 equals 2 ln of 2 root 3. So, like I said, we're going to not get overwhelmed. We're going to just use some log properties here, which we all know and love. Ln of x minus 9 plus ln of x plus 2, well, I'm going to condense that to ln of x minus 9 times x plus 2, right? That's how we add two logs with the same base, by multiplying their two arguments, condensing it to a single log. And over here on the other side of the equation, I have 2 ln of 2 root 3. I have that coefficient of 2. I'm going to make my little power rule. I'm going to raise the argument to the second power. So now over here, I'll have ln of 2 root 3 squared. Now when you square 2 root 3, of course, just be careful. You got to square the 2 and the root 3. Squaring 2 will give you 4 multiplied by root 3 squared, which is 3, and that will give you ln of 12. Over here, ln of x minus 9 times ln of x plus 2, that's a little FOIL action. So, depending on how good you are with these things, you might be able to do it in your head. You get x squared. Your outers, you get 2x. Your inners, you get minus 9x. Combined, that will give you minus 7x. And minus 9 times 2 is minus 18. So you see in this problem, just by doing a little manipulating with my log properties, I've got it down to log equals log, or in this case, ln equals ln. And this is the one-to-one property. If ln of this equals ln of this, well, hey, my next move is that the only way these two things are equal is if the arguments are equal. So you set the insides equal to each other, and we solve from here. Now I'm solving a quadratic, so this should be hopefully almost autopilot at this stage of your math career. We're going to subtract 12, bring it all over to one side, and I'm going to try to factor. If not, I may have to use the quadratic formula, but thankfully this does factor, I believe. Yes, we're looking for two numbers, x and x. We're looking for two numbers that multiply to negative 30 and add up to negative 7. That would be minus 10 and positive 3. And then when we set each factor equal to 0, we get x equals 10. and x equals -3. Yay, I'm done, right? However, you're not done because you got to remember with logs have domain restrictions. Logs are sometimes undefined. So any solutions you have must be in the domain of these logs. In other words, you can't make any of the initial logs here, back in the original problem up here, before I did any condensing or expanding, I can't have any x value that makes the insides be 0 or negative, because that's when logs are undefined. So this shouldn't be a big complicated algebra move to check. It's just remembering to do it at all. So for example, if you were to plug in +10, you can plug in the whole thing and simplify, but really I'm just checking for, if I plug it in right here into x minus 9, does it make the inside be negative or 0? No. So that's good there, but I also got to check this. There's a second log, and if I plug x in there, 10 plus 2 is 12. Obviously that's going to be positive. And over here there's no variables to plug into, so 10 is good. 10's good, it checks out. -3, however, if you plug -3 into this first log right here, -3 minus 9 will give you -12. The ln of -12, or any log of -12, is undefined. It's also undefined if you plug it here, -3 plus 2. So, but if it even makes one log undefined, then that is not in the domain of the whole equation, so we cross that out. It's what we call an extraneous solution. Great vocabulary word there, right? Extraneous solution. So the only actual solution is x equals 10. And that's a classic thing. Sometimes both answers will work, sometimes neither will work, and you'll be left with no solution. And a lot of times only one might work. But definitely got to remember to check for those extraneous solutions. All right, so now let's check one more problem here. We've got log base 2 of 3x plus 4 minus log base 2 of x minus 1 minus 5 equals 0. Now in this case, hopefully you can kind of, you're developing sort of a sense for how these are going to go. I've got log base 2 minus another log base 2. I'm going to condense those to log base 2 of, now when we subtract two logs with the same base, remember that is condensing by dividing their arguments, 3x plus 4 over x minus 1. And remember, you're subtracting exponents essentially when you subtract logs. Logs are just exponents. And when do we subtract exponents? When we're dividing. So that's what causes that division on the inside. Now this, I'm left with this minus 5 just kind of hanging around outside though. That's not part of a log, so I can't condense it. So this is where I would really just move that to the other side of the equation. Whoops, that was bad parentheses placement there. And I'm going to add 5 to the other side. And now see, I've got that first scenario I was talking about, not log equals log, but log equals a number. And if you can do this, well, hey, then our next move is, how do I clear the log? You rewrite it in exponential form. What's the base? The base is 2. And log base 2 of this equals 5 is like saying 2 to the 5th equals 3x minus 4 over x minus 1. Oops, that's 3x plus 4. And now you see, hey, now it's just an equation. There's no log in it. So now it's just algebra again. So 2 to the 5th is 32. And now, hey, just solve this, cross multiply, whatever you like to do. Going to cross multiply there. 32 times x minus 1 will be 32x minus 32. Don't forget to distribute. Equals 3x plus 4 times 1. 3x plus 4. And solve for x. Get your variable on one side, constants on the other. So I'll have 29x when I'll subtract 3x from both sides. Add 32 to both sides. I'll have 29x equals 36. Divide by 29. X equals 36 over 29. That does not reduce. You could use a mixed fraction if you like, or 1 7/29, either or. But remember, it's still a log problem that has, logs in the original equation, so you've got to make sure your domain is satisfied. You got to make sure this solution is included in the domain. And 36/29, or 1 7/29, or convert it to a decimal if that makes it easier for you. You got to make sure that if you plug it into the original logs, it doesn't make either one undefined. And of course, if you plug in 1 7/29 into here, multiplying by 3, adding 4, that's going to be positive. So you're good there. If you plug it in here, 1 7/9 minus 1 is still positive. It's 7/9. So it's good here as well. It doesn't make either of these logs undefined. Then we're happy. That's our final solution. It checks out. And there we go, kids. So those are two different log equations, and they all basically boil down to one of those two scenarios. So hopefully this clears things up a little bit. If not, feel free to reach out for questions or look at the lots of different examples we've covered in class, so maybe you get the hang of it. But hang in there and keep working hard, because I know logs can be a little frustrating. Okay, kids, take it easy.